Our presentation is about application of chromatography in law enforcement.
What is chromatography? Chromatography is a technique in which the components of a mixture are separated based on difference in the rates at which they are carried through a fixed or stationary phase by a gaseous or liquid mobile phase. It's a history of chromatography. The first true chromatography is usually attributed to the Russian-Italian botanist Mikhail Zverk. Zverk applied his observation with filter paper extraction to the new method of column fractionation that had been developed in the 1890s for separating the component of petroleum. He used a liquid adsorption column containing calcium carbonate to separate yellow, orange, and green plant pigment, what are known today as xanthophylls, carotenes, and chlorophylls, respectively. The method was described on December 30, 1901 at the 11th Congress.
Chromatography plays a significant role in forensic science, particularly in the analysis of substances found at crime scenes. It is used to separate and identify complex mixture of compounds which can be crucial in criminal investigation. Here are some specific applications. Number 1 is drug analysis, which commonly use chromatography, gas, and high-performance liquid chromatography. The next one is toxicology. Forensic toxicologists use chromatography to identify and quantify toxins, poison, or alcohol levels in bodily fluids, which can aid in determining causes of death. Number 3, arson investigation. Gas chromatography can help identify accelerants used in arson by separating and identifying petroleum-based products. The fourth one is DNA and fiber analysis. The thin layer chromatography, TLC, can sometimes be employed to separate and identify different dyes and fiber from clothing linking suspect to crime scenes. The last one is drug impurities. Chromatography helps forensic scientists examine the impurity of use of drugs.
So next I'm going to explain on the classification of chromatography method. So the classification consists of two types, which is planar chromatography and column chromatography. So first I'm going to explain on the planar chromatography. So the position of the stationary phase for planar chromatography is supported on a plate or in the pores of a paper, and the movement of mobile phase is through capillary action. The example of planar chromatography is paper chromatography and thin layer chromatography. But although both of them practice follow very similar principles and methods, they use different material as bed or lens for the stationary phase of the process.
The second one is column chromatography, which is described as the useful technique in which the substances to be isolated are presented onto the highest point of a column loaded with an absorbent stationary phase. Go through the column at various rates that rely upon the affinity of the every substance for the absorbent and the solvent or solvent mixture, and are typically gathered in solution as they pass from the column at various times. Stationary phase is held in a narrow tube. Mobile phase is forced through the tube under pressure or by gravity. Example of column chromatography is gas chromatography and supercritical fluid chromatography.
Now I'll be explaining about methodology. In forensic chromatography lab, the most common method used is gas chromatography. In most cases, the mixture is added to a simple injector where it is heated and vaporized in a column oven. As the name implies, gas is used in this type of chromatography as the mobile phase. The carrier gas such as helium, hydrogen, nitrogen, or a combination of argon and methane moves the vaporized mixture towards the stationary phase. In gas chromatography, the stationary phase is a cut column. The compound in a mixture are separated based on the different strength of the molecular interaction that we use in crime law enforcement is planar chromatography. Basic planar chromatography technique can be used to identify if two linked samples are likely to be the same. For example, the in use If that bill is stolen, then a forensic scientist may be able to see if the same ink can be detected on the hands of the thief.
C is a column chromatography method using a solid stationary phase and a liquid mobile phase. However, unlike liquid chromatography method, where the mobile phase is slowly dripped through the column, it is pushed through the column at high pressure. HPLC can be used to analyze explosives, as different substances used in explosives have different properties and therefore will have different retention times. Certain drugs can also be detected by HPLC. So for the conclusions, chromatography is a fundamental analytical technique in forensic science. It is used to separate, identify and analyze complex mixture of a substance. It plays an important role in examining evidence such as inks, drugs, explosives and biological samples like blood or saliva. The simplicity, accuracy and versatility of chromatography methods such as thin layer chromatography, TLC, gas chromatography, GC, and high performance liquid chromatography, HPLC, make them indispensable for forensic investigation.